Dear students, Assalamu alaikum. You are welcome in this session. Our course is Research Methodology, and our textbook is Research Methods for the Behavioral Sciences, written by Frederick Gravater and Lorianne Forzano. Today, we are going to discuss the scientific method. The scientific method includes many parts. These parts come from the methods we discussed earlier. As you know, we have discussed 5 non-scientific methods. This scientific method combines different ways of gaining knowledge. We do this so we do not rely on just one method. We use scientific method so we do not rely on just one non-scientific method. Using only one method can create problems. Mixing methods helps us avoid those problems. The scientific method is a carefully designed system. It helps us ask questions in the right way. It also helps us answer those questions properly. The main goal of scientific method is accuracy. Accuracy means correctness. We want the answers we find to be as correct as possible, accurate answers. The steps of the scientific method. Step 1. Observe behavior or other phenomena. The scientific method often begins with simple observations. Casual or informal observations. You do not need a detailed plan at the beginning. You do not need a detailed plan at the beginning. In fact, I am also admitting the newcomers on the Google Meet. Uh, you do not need a detailed plan at the beginning. You do not need a formal investigation right away. Just observe the world around you. This is the first step of the scientific method. Keep watching until something catches your attention. It could be a behavior, it could be an event. Your first observations may come from your own experience. Afra says she can't hear me. I think others can hear me. अफरा को बताएं कि वो मुझे YouTube पे ज्वाइन करें. So the authors say your first observations may come from your own experience. This connects to the method of empiricism. In empiricism, as we discussed, it also is based on observation. You may watch other people's behavior. You may notice your own behavior. For example, you might see strangers in an elevator. You may notice they carefully avoid eye contact. Or one day, you may sit in the back row of a class. You may notice students around you are not paying attention. After observing, you start asking questions. Why do people avoid looking at each other in elevators? Elevators are lifts which are used in buildings to go upstairs. Do better students really sit in the front row? You may ask a question. Observations can also come from others. Sometimes your interest comes from someone else's observations. You might read about research findings. Research findings of others are others' observations. This connects to the method of authority. You might hear people talking about things they have seen. In any case, something catches your attention. It starts raising questions in your mind. Generalization and inductive reasoning. At this stage, people often go beyond what they directly observed. When people observe, then they think. They begin to generalize. Generalization is a natural human habit. It is called induction or inductive reasoning. Inductive reasoning means making a general conclusion. Making a general conclusion is called generalization, and its method is inductive reasoning. You base it on a few specific examples. जवेरिया क्या है, उसको आवाज़ नहीं आ रही. जवेरिया से कहें कि वो मुझे यूट्यूब पे. हाँ, उसने सोनिया ने कहा कि मेरा नाम कुछ और शो हो रहा है. इट्स ओके. तो जवेरिया को बताएं कि वो यूट्यूब पे मुझे ज्वाइन करे. You base it on a few specific examples. Okay, let me also, मैं WhatsApp पे ना इनको बता देता हूँ कि join me on YouTube as well. Join me on YouTube also. Okay. Yes. So you base it on a few specific examples. For example, imagine you taste a green apple. It is sour. It is not sweet. You taste a second green apple. It is also sour. You taste a third apple. It is sour too. Soon you conclude that all green apples are sour. Notice what happened. You tasted only 3 apples, but you made a conclusion, general conclusion, about millions of green apples in the world. That is inductive reasoning. This is how we do induction. Example, weather and mood. Let's combine observation and induction. This shows how the first stage of the scientific method works. Imagine it is late October. For 3 days in a row, the weather is dark, cold, and gloomy. You notice that you feel a little depressed. It is not serious clinical depression. You just feel that summer is over. The carefree days are gone. In cold countries where winters are very cold, the weather is very cold, in especially in northern Europe and northern America. So people like summers. They don't like winter because it is too cold. Here in our region, particularly in southern Punjab, because it is very hot, we don't like summer. We like winters because they are relatively good. So the authors of this book, they are from a cold country, cold region. So they are giving that example. The carefree days are gone. Now, long, cold winter months are coming. As you move through your day, you start wondering, do other people feel the same way? You begin watching your friends and colleagues. You observe their mood and behavior. Soon, you reach a general conclusion. People seem sadder and more depressed in winter than in summer. People are uh, People in cold countries, they seem sadder, more sad, and more depressed in winter than in summer. Looking for existing knowledge. At this point, you might go to the library. You can go in person, you can go physically, or you can search on the internet. You look for what others have already discovered about winter and depression. Usually, you will find a lot of information. You will see theories, you will see opinions, you will see real research studies. This is existing knowledge. It connects to the method of authority. At the end, I will ask you some questions. Okay, so be present and be attentive. So, when you consult the library online or in person, it connects to the method of authority. This information may answer your question. It will usually help you understand the issue better, but maybe you still have questions. Maybe you are still curious. If that is true, you are ready for the next step in the scientific method. What is the second step? Form a tentative answer or explanation, a hypothesis. You form a hypothesis. Thesis. It is from thesis. Hypothesis means like a thesis. It is not a complete thesis, but it is like a thesis. This step usually starts by identifying other factors. These factors are also called variables. Different factors in research are called variables because they vary, they change with time. These variables are linked to what you observed. For example, think about winter and depression. Winter is also a variable because it changes. The temperature changes in on different days. Depression, it also changes in quantity. It is also a variable. Ask yourself what other variables are connected to winter and depression. You can identify variables by using common sense. You can also use background research. This research can be done in the library or it can be done on the internet. The link between winter and depression may involve other variables. One variable could be weather. One variable could be weather. Winter weather is often cold. Winter weather is often cold. It is often dark. It is often gloomy. These conditions could lead to depression. In winter, people often get sick. They may catch colds. Sneezing. Many people sneeze a lot in winter. They may get the flu. Being sick could also lead to depression. A quick library research helps here. The search shows that several variables have been studied. These include atmospheric conditions, they include seasonal changes, they include health. All of these have been studied in relation to depression. Now, notice something important. We have at least two possible explanations. These explanations relate to the observation. People seem more depressed in winter than in summer. Health. The first variable is health and the health explanation. People tend to catch colds and get the flu during the winter, and perhaps their illness leads to depression. So maybe it is their illness that leads to gloomy mood, bad mood, or depression. Maybe it is not winter itself. The second is the weather explanation. Perhaps people become depressed in the winter because the weather is literally dark and depressing. So maybe there is little sunlight. So darkness causes the depression, not winter itself. Next, you must choose one explanation. This explanation will be tested in a scientific research study. You can choose the explanation that seems most reasonable to you, or you can choose the one you find most interesting. Remember something important: the other explanation is not rejected. Although you choose one explanation, the other explanation is not rejected. It is not thrown away. If needed, it can be tested later. It can be examined in a second study. At this stage, you now have a hypothesis. A hypothesis is a possible explanation for what you observed. What are the hypotheses? Let me repeat. A hypothesis is a possible explanation for what you observed. Your hypothesis is not a final answer, it is a tentative answer. It is not the truth yet. Instead, it is a tentative answer. This means it is temporary, it is meant to be tested, it is meant to be carefully and critically evaluated. Definition of a hypothesis. Hypothesis is a statement that describes or explains the relationship between or among variables. It is a hypothesis. Step 3. Use your hypothesis to generate a testable prediction. Usually, this step means taking the hypothesis, you apply it to a real situation. The situation must be specific, it must be observable, it must exist in the real world. For example, imagine your hypothesis says this: winter depression happens because the environment is darker. From this idea, you make a specific prediction. One prediction could be this: if lighting is reduced on the third floor of a college dorm means dormitory, hostel. If lighting is reduced on the third floor of a college hostel, then depression should increase among students living there. Or the opposite could also be predicted. If lighting is increased, then depression should decrease. Another possible prediction is this: cities with more sunshine should have less depression, and cities with less sunshine should have more depression. It can be a possible prediction. For example, Phoenix has about 211 clear days each year. It receives about 86% of possible sunshine. Seattle has about 71 clear days each year. It receives about 43% of possible sunshine. Based on the hypothesis, we would expect this result: depression should be higher in Seattle and lower in Phoenix. Notice something important here. उस पर मुझे यूट्यूब पे ज्वाइन करें भाई, यूट्यूब पे आवाज़ आ रही है. Join me on YouTube. Let them know, join me on YouTube. So notice something important here. One single hypothesis can produce many predictions. One single hypothesis can produce many predictions. Each prediction is about a specific situation. Each situation can be observed. Each situation can be measured. We can do measurement. Figure 1.2 shows this process. In your book, you can see figure 1.2. Notice how we are thinking here. We are using logic. This is called the rational method. This type of logic is called deduction. It is also called deductive reasoning. First, we have discussed induction. Now, we are discussing deduction. Deduction starts with a general statement, then it moves to specific conclusions. So, it is opposite of induction. In induction, we take some few examples and then we generalize. In deduction, we take a general statement and then we come to specific conclusions. In this case, the hypothesis is the general statement, the predictions are the logical conclusions. If the hypothesis is true, then these predictions should logically follow. Induction and deduction work together, they support each other. Induction starts with specific examples. It uses them to form general ideas or hypotheses. Deduction does the opposite. Deduction does the opposite. It starts with general ideas. It uses them to create specific predictions. This relationship is shown in figure 1.3. Also notice another key point. Predictions must be testable. They can be tested. This means we must be able to check predictions. We must be able to observe them directly. The prediction must be shown to be either correct or incorrect. The observations will do one of two things. They will support the hypothesis or they will refute the hypothesis. For a prediction to be truly testable, both outcomes must be possible. Both outcomes must be possible. People are joining again and again on. Okay, for a prediction to be truly testable, both outcomes must be possible. Definition of deduction. A deduction or deductive reasoning uses a general statement as the basis for reaching a conclusion about specific examples. It is deduction. Inductive reasoning starts with a small number of observations. These observations are limited. From these few observations, it creates a general hypothesis. Deductive reasoning starts in a different way. It begins with a general hypothesis, or it begins with a general premise. From that general idea, it creates a prediction. This prediction is about specific observations. Step 4. Evaluate the prediction by making systematic planned observations. When you make a specific and testable prediction, you use the rational method. The next step is to test that prediction. This is done through direct observation. This uses the empirical method. This stage is the actual research phase. It is also the data collection phase. It is a core part of the scientific method. The main goal is fair testing. The goal is also unbiased testing. The researcher wants to test the hypothesis honestly. The researcher observes what really happens. Then the researcher checks if the prediction is correct. The researcher must be very careful. They must observe exactly what happens. They must record the results accurately. Personal opinions must not interfere. Personal expectations must not influence the results. There should be no subjective interpretation. Subjective interpretation means which is according to your like or dislike. So, science is not based on likes and dislikes. Science is not based on subjective interpretations. It is based on objective interpretation, which is neutral, which that is unbiased. For example, imagine a college dormitory or hostel. On one floor, all lamps use 100-watt light bulbs. On another floor, all lamps use 60-watt light bulbs. The students live under these lighting conditions. This continues for 6 weeks. After 6 weeks, all students are tested for depression. The scores from both groups are collected. The two sets of scores are compared. This comparison helps answer a question. Is there a relationship between light level and depression? Is there a relationship between light level and depression? This research study is an empirical test. It directly tests the research hypothesis. Step 5. Use the observations to support, refute, or refine the original hypothesis. The final step of the scientific method to compare the results. You compare the actual observations with the predictions. These predictions came from the hypothesis. You ask a key question. How closely do the observations match the predictions? If there is some agreement, this supports the original hypothesis. When there is support, you do not stop. You think about making new predictions. Then you test those new predictions. If there is little or no agreement, this means there is a problem. The hypothesis may be wrong, or the hypothesis may have been used incorrectly. This can lead to faulty predictions. In this situation, you may revise the hypothesis, or you may rethink how the predictions were made. In either case, you go back to step 2. You form a new hypothesis. You get ready to make new predictions. Example, lighting and depression. Suppose the researcher finds this result. Students on the brightly lit floor show less depression, where bulbs have 60 watts. Students on the dimly lit floor shows more depression, where bulbs are 40 watts. This result supports the original hypothesis. It suggests that lighting matters. Lighting should be considered when explaining winter depression. Now, suppose something else is also found. Some students with bright lights are still depressed. It is possible. Students living on the floor where bulbs are more powerful, 60-watt bulbs, some students are found depressed over there as well. Some students with dim lights are not depressed at all. This tells us something important. Lighting is not the whole answer. Suppose there is no difference between the two groups, then we must consider other possibilities. Maybe lighting does not affect depression, or maybe the lighting difference was too small, or maybe it did not last long enough. In any case, we need to look at other factors. We need to test other hypotheses. Only then can we fully explain winter depression. The scientific method is a continuous process. Notice an important pattern. The scientific method keeps repeating the same steps. Observations lead to a hypothesis. The hypothesis leads to a prediction. The prediction leads to new observations. New observations lead to another hypothesis. This process continues again and again. The scientific method is not a straight line. It does not move from start to finish just once. Instead, it is circular. It is like a spiral. With each cycle, we learn more. With each cycle, knowledge grows. This is shown in figure 1.4 in your book. The definition of scientific method. The scientific method is a method of acquiring knowledge that uses observations to develop a hypothesis, then uses the hypothesis to make logical predictions that can be empirically tested by making additional systematic observations. Typically, the new observations lead to a new hypothesis and the cycle continues. So, with this, our today's discussion on scientific method is over. You can ask questions or make comments if you have.